When you are working with standard reduction potentials, it's important to realize that voltage is an intensive property. And by the end of the video, you'll understand what I mean by the word intensive. We're going to use this first half reaction here as an example. So this is the reduction of silver ion to silver metal. So we have Ag plus an electron gives us solid silver. The standard reduction potential is positive 0.80 volts for this half reaction. And we're going to start by calculating the standard change in free energy. So from an earlier video, we know if we have the voltage, right, we can find the standard change in free energy, delta G0. So for this half reaction, it would be equal to negative. Remember that N is the number of moles of electrons, and here we have 1 mole of electrons, so we have 1 mole. So we plug that into our equation. Next we have F, which is Faraday's constant, and from an earlier video we know that's 96,500 coulombs per mole. So it's the charge of 1 mole of electrons. We need to multiply that by the voltage, which was 0.80. So this is 0.80. Instead of writing volts, I'm going to write joules per coulomb here so we can see our units cancel. So moles of electrons cancels out, charge coulombs cancels out, and so we should get our answer in terms of joules. So this is equal to negative, and let's figure out what it is. So this would be 1 times 96,500 times 0.80, and it should be the negative of that. So negative 77,200 joules, which I'll just say is negative 77 kilojoules. So we get negative 77 kilojoules is the change in free energy that accompanies the formation of 1 mole of silver. All right, what about if we wanted to form 2 moles of silver? So we need to multiply everything in our half reaction by 2. So we get 2 Ag plus, so 2 moles of silver ions, plus 2 moles of electrons should give us 2 moles of solid silver. Right? What would be the standard change in free energy that accompanies the formation of 2 moles of solid silver? Well, let me change colors here. If this is the standard change in free energy for the formation of 1 mole of solid silver, then we should just be able to multiply that number by 2, right? So negative 77 kilojoules times 2 gives us negative 154 kilojoules. So that's the standard change in free energy that accompanies the formation of 2 moles of silver. So free energy is what's called an extensive property. So it depends on how much you're dealing with here. So we're dealing with 2 moles of electrons and the formation of 2 moles of silver. So we have to change the standard change in free energy accordingly. All right, what about the voltage? All right, so we have our standard change in free energy. Let's use this equation again to solve for the voltage. So we're going to plug in negative 154 kilojoules in for our standard change in free energy, and we need to make that into joules. So that's negative 154,000 joules. And that's equal to, let me change colors again here. This would be equal to negative, right? So we have a negative sign, and then N is number of moles of electrons. Well, now we're saying 2 moles of electrons. So this would be negative 2 here. And then multiply that by Faraday's constant, right? So we have Faraday's constant, which is 96,500. And then we can solve for the voltage. So we can solve for E0. So let's plug that in on our calculator. We have negative 154,000, right? We need to divide that by negative 2, and then divide that by Faraday's number. So Faraday's constant, I should say. So 96,500, which gives us a voltage of 0.80. Right? So if we round that, we get a voltage of 0.80 volts. So it's the same voltage to form 2 moles of silver as it was to form 1 mole of silver, right? Let me highlight that. So let me change colors here. So we had a voltage of 0.80 volts to form 2 moles of silver. That's the same voltage to form 1 mole of silver. So voltage is an intensive property. It's the same. It doesn't matter how much silver you're forming, how many moles of electrons you're using, the voltage is the same. And it's important to remember that when you're doing your standard reduction of potentials, because if you need to do something like we did up here, multiply a half reaction by 2, you don't multiply the voltage by 2 because voltage is an intensive property.